Section 5.5, part 3. If you're here watching, it's because you want to know why Newton's method works. It's pretty cool, actually. So I'm going to kind of walk you through it, and we're just going to wind up with that same formula you had at the end of the last video. So the idea is Newton's method actually uses tangent lines. Okay. So think about this picture. Let me show you what I've drawn here. I've drawn some curve. Whoa, gosh, that's no good. Sorry about that. I've drawn some curve. Oops. And that curve crosses the x-axis right there at that point. And I'm trying to guess that. Okay. So what I'm going to do is I'm going to start with a guess. So here's my guess. Pretend this is really blown up. It's not as far away as it looks. The general idea of Newton's method is this. That as long as I'm close, as long as my guess was close and I'm not way out in the boonies somewhere, look at my tangent line at that point. The tangent line at that point, notice, is going to cross the x-axis right there. The idea is it's going to cross the x-axis closer to the real answer than my first guess. I'll do it again so you can see it. Now, if I do it again, now I'm going to use this point right here. Notice my next tangent line's even better. It doesn't take you very long to start getting closer and closer and closer to the point. So it uses the idea of tangent line, the x-intercept. Here's the idea. The x-intercept, not y, of tangent line is a better guess than whatever you had. And I'll show you why. Or not show you why, I'll show you how to get that. All right, so first things first, I need to find the equation of that tangent line. So what I did was my original point. Let me clear this up a little bit so there's, oops. Get all the color off there. So my original point was right here at x1, f of x1. Okay, and my function was y equals f of x. So I just drew a tangent line, which is y minus y1 equals slope times x minus x1, or y minus f of x1, which is my y value, equals the slope, which is derivative, times x minus x1. So I'm writing the tangent line. I'm physically, even though I don't have any numbers here, it's just x's and y's, I'm going to find that tangent line. All right. Once I have that tangent line, I'm calling this next point over here x2. Call it whatever you want. But we're going to try to find that x-intercept. So we're going to call it x2 comma 0. We know there is some x2 somewhere. It's on the line. So what we're going to do is we're going to stick that point into my tangent line, because any point that's on that line has to work in the equation. So there's my 0. This 0 is that 0. And that x2 is my x. It's just getting plugged in for the x. Everything else is exactly the same. Next step is to do some solving. Really what we're trying to do is solve for x2, right? We're trying to solve for x2. So my first step was to divide both sides by f prime of x1, which left me with this. And then I'm going to add that x1 to both sides. And there I get Newton's rule, right? We'll just formalize it, or Newton's method. We'll just formalize it to be the same thing we had before. The new guess is the old guess minus the functions at that point divided by the derivative at that point. It's the same thing as that. So that's kind of a quick, it's not super important that you understand why that works. I think it's cool if you do understand it, but that's Newton's method in a nutshell as to why it works. It is just a calculator plug and chug type problems for sure. Typically, if we were to do a problem like this on a real AP test, we probably wouldn't let you do it on the calculator. So we just make the numbers really nice and really simple and really easy to work with. The problem is we can't really let you use your calculator to do these problems because your calculator can find those zeros, right? You might not know how to do that, but they can. So for the time being, just use your calculator to add, subtract, multiply, divide, and save yourself some time. That's that.